Activity 5 is lesson 5.1 and 5.2, and it's about irrational numbers. Our learning targets are to approximate an irrational number in terms of irrational and compare and order irrational and rational numbers. Vocabulary: irrational numbers are real numbers that cannot be written as a ratio or fraction, and rational numbers are real numbers that can be written as a ratio or fraction. To go into a little bit more detail, irrational numbers are non-repeating, non-terminating decimals with no patterns, versus rational numbers where all of our repeating decimals, all of our terminating decimals, all of our fractions, integers, whole numbers, and natural numbers. The irrational number that comes to mind for most people is pi, because it's non-repeating, there's no pattern, it goes on forever, but we could approximate it in terms of irrational, so we usually estimate it at about 3.14. Example 1, we want to estimate the square root of 11 to the nearest tenth. We typically look at a number line to do this. You look at your perfect squares that go above and below. So below 11, the first perfect square is square root of 9. Above 11, the perfect square is 16. We know 11 is somewhere in the middle. The square root of 9 is 3, the square root of 16 is 4, so I know that 11 is 3 point something. So the idea is we need to figure out, is it closer to the 9 or closer to the 16? It's definitely closer to the 9, because 9, 10, 11, it's only, 2 away, versus 16, it's 5 away. So if I'm just thinking I want to split from 9 to 16, let's see, here's 9, 10, 11, 12, 13, I'm just going to go by ones. These are my square roots up here. So down here I'm going to put the whole number. Halfway in between would have been right here. So this is 3.5. So in between the 3 and the 3.5 is 11, the square root of 11. So let's see, this would be 10, 11, 12. I'm going to call it about 3.3. That's my estimation. In example 2, we actually want to do the cube root of 20. With cube roots, you do the same thing, but we think about the cube root of 8 is 2. The cube root of 27 is 3, which means that the cube root of 20 is going to be closer to 3 than it is 2. Directly in between 27 and 8 is 17.5. So I know it's going to be bigger than 2.5. So if I was going to estimate, I'm bigger than 2.5. Let's mark right here. Here's 27. Here's 8. Here's 20. This is 2. This is 3. And this is what we're trying to figure out. So let's see. 17.5 is our halfway point. That's 2.5. So 2.6, 7, 8, 9, I don't know. I'm going to call it 2.6 to 2.7, somewhere around there. And then once I get my estimation, I'm just going to check in my calculator. So in my calculator, I'm going to type in the cube root of 20. and it tells me that it's 2.71442, and it keeps going and going, so 2.7 is our estimate. Example 3, find examples of a rational number and an irrational number between 4.8 and 4.9. Between 4.8 and 4.9, if I want it rational, I could just do 4.85. That's right in between. For irrational, I would want a number that doesn't terminate and doesn't repeat. And I could sit here and try to find a square root that goes in between, something that's bigger than 16. What if I did the square root of 17? Nope, have to be bigger than that. The square root of 24 is approximately 4.898 or 899. So that's my irrational. So I'm using my calculator to do some guessing and checking. But I knew to start with somewhere above 16 and then go under 25. And then last but not least, put these in order from least to greatest. I am just going to use my calculator to help me. But I find the square root of 71 is about 8.43. I have 9.3, and the square root of 84 is about 9.17. So if I go from least to greatest, the smallest one I see is 8.1. Then square root of 71. Square root of 84 and 9.3, and I'm just turning them into